This video series talks about how historical archaeology is done and how it relates to, uses, and is both the same and different from history and other sciences such as earth sciences and chemistry. Each video segment can be used on its own, or they can be watched in sequence as a part of a series. If you have any questions about the series or would like to learn more, please contact the Aucilla Research Institute. We are happy to help. A lot of people have heard of archaeology. When most people think of archaeology, they think of pyramids in Egypt, or Roman ruins, or people digging in faraway places. But did you know archaeologists work in many places right near you? Archaeology is the science of learning about the past through material remains. That is, the things that people left behind. They can be things as simple as stone flakes or potsherds, or really huge things like buildings, monuments, and tombs. All of these things can tell us about the ways that people lived in the past. History is the discipline of learning about the past through documents and written records. Historians use things like maps, diaries, written accounts, paintings, and drawings, and other things as ways to understand what people were doing in the past. Historical archaeology is the archaeology of the time we have written records of the past. Historical archaeologists use both documents and artifacts to understand things that were happening long ago. So, if we have written documents that tell us what was happening in the past, why would we want to do archaeology? What could archaeology tell us that the written documents don't? A lot. It's important to remember that a lot was happening in the past didn't get written down, even when people made written records. Sometimes the people who made the records didn't write about other groups of people, such as Native Americans. Sometimes people took for granted the ways they did things, such as building houses or making things, and didn't write down how they did it. And sometimes people either forgot things or didn't write things down accurately for reasons of their own. Doing archaeology at historical sites can help people living today set the record straight. Through studying the physical things people left behind, the remains of their buildings, the remains of the things they used to live, and even sometimes the remains of the people themselves, we can add a lot to what we know about the ways people lived in the past. Join members of the Aucilla Research Institute as we take you on a series of journeys into historical archaeology at several important sites in Northwest Florida. On these journeys, you'll learn how historical archaeology uses history, science, math, and specialized tools to look into the past and bring the people there to life. Have you ever wondered, how do archaeologists decide where to dig, or even if to dig? What exactly is it that makes archaeologists choose specific sites for digging after they've decided whether or not digging is necessary? In this video, we're going to talk about the ethical and legal rules that archaeologists follow, how archaeologists learn where sites are located, and make the decision of whether or not to dig at all. Believe it or not, archaeologists don't always dig at sites. In fact, the rules of the Register of Professional Archaeologists say that archaeologists should actually only dig in two cases. Number one, where digging is needed to protect a site that's being destroyed, or number two, where digging is the only way to answer research questions about a site. And if an archaeologist needs to dig, they're required to leave as much of the site intact as possible. Why is that? Back when archaeology was a new science in the later 1800s, archaeologists like C.B. Moore, one of the first American archaeologists, dug at sites mainly to find intact artifacts. They didn't know that things like charcoal or soot would one day let archaeologists find dates, and they didn't realize that a lot of artifacts needed to be caught during screening to get a full picture of the site. Today, on the other hand, we realize that archaeologists in the future are likely to have technologies that let us understand more about sites, like radiocarbon dating and other tests that tell us how artifacts were made and used. That means that sites need to have areas left intact so future researchers can learn more. So, how do historical archaeologists decide whether and where to dig? First, historical archaeologists, like historians, normally begin their research in the library. We use historical documents to try to figure out where people lived in the past and what kind of things we might find at sites. Then, archaeologists reach out to people who live in the area and ask them, have you seen places where there are artifacts on the ground? Do you know of areas that might be archaeological sites? People who live in different areas know their communities best, and they can tell archaeologists not only where sites may be, but what kind of questions about their past that they'd like to see answered. Finally, when archaeologists have an idea about where sites may be, they create a research design. A research design is a set of research questions that the historical archaeologist would like to answer. Hypotheses inform guesses about how people in the past may have lived that they want to test, and based on the questions and hypotheses, the things they think would be present in an archaeological site if their hypotheses are true. At this point, a historical archaeologist has done all they can before going to the field. Now it's time to test their ideas in the real world. Remember that through research in the historical documents, asking people who live in an area, and through making a research design, historical archaeologists choose the areas that they want to do their field research. So, do they now begin to dig? No. Remember, archaeologists only dig when they need to dig to protect a site, or when they need to dig to answer a research question. If a historical archaeologist can answer their research questions without having to dig, that's the best way to answer them. One way a historical archaeologist can answer questions about a site without digging is called surface survey. In surface survey, the archaeologist walks the surface of a site in regular lines called transects to see if there are areas of the site that have artifacts or features on the ground surface. If there are, the archaeologist will record the areas where they're found and make a map of the site that shows where the locations are and how they relate to each other. Archaeologists use the word artifacts a lot, but what are they and what are features? An artifact is anything made by people that can be moved out of its context, the place where the artifact was found. Things like pottery sherds, stone tools, glass fragments, metal tools or tool parts, or bone fragments from meals that people ate would all be considered artifacts. A feature, on the other hand, is something made by people that can't be moved out of its context without destroying it. Things like earthwork mounds. stands where posts were, and building foundations are all features. Artifacts and features together show that an area represents an archaeological site. If these can be identified by doing surface survey only and answer a research question, digging at the site may not be necessary. What if something on the ground surface is covered by trees and vegetation and is hard or impossible to see? In the 21st century, historical archaeologists now use LIDAR, a word which is short for light detection and ranging. LIDAR works by using a laser flying overhead to strike the Earth's surface and reflect upwards to a receiver. As the LIDAR works, it creates a map of the Earth's surface that strips away the vegetation cover and makes features visible. Sometimes entire sites can be found by using LIDAR alone. At a historical archaeological site, one tool that can be very helpful is the use of metal detectors. If a building was made of wood, even if it rotted away or burned down, the nails and metal that helped hold it together are left in the ground. Using a metal detector, archaeologists can find the locations of metal hits and plot them out on a site map, which can help find the locations of building features. Finally, another way to check below the ground surface without digging is through the use of ground penetrating radar, or GPR for short. With GPR, a radar beam is sent into the ground and reflected off of anomalies, places below the ground where the soil has been disturbed or dug or hardened through human activity. These GPR images can give a historical archaeologist an idea about what kinds of things may be below the surface at a site. Altogether, these types of non-invasive technologies and techniques may be able to answer a number of research questions about the site a historical archaeologist is studying. If they can, then the best choice is not to dig the site. But if they can't, then the next stage at a site is the first one to go below the ground. All right, at this stage, the principal investigator, the historical archaeologist working on studying a past human culture at a specific site or sites, now has a decision to make. Research with historical documents and non-invasive techniques have taken us as far as they can go. In order to answer our research questions, we're going to need to dig. Now we have to answer two big questions. Where and how do we dig? In order to answer both questions, we need to know what parts of an archaeological site might be most likely to have the information we need to answer our research questions and to test the hypotheses we've made about the site. How do we decide? First, we use the information we've already gotten about the site from non-invasive studies. For example, if we have areas where metal detecting has found concentrations of metal, LIDAR images that show features in certain areas of the site, or ground penetrating radar anomalies that suggest there's something below the ground surface in some areas. All of those suggest that these may be places we want to dig. Second, however, before we even dig there, it's important to remember that a lot of different things may have been happening at an archaeological site when people lived there. Some of these things may not be detectable by our non-invasive studies. So how do we decide how different areas at a site might be related to each other? Before an archaeologist digs in specific areas, it's normally the best idea to start with subsurface testing. Subsurface testing means setting up a place to measure from, usually called a site datum, and laying out a grid, a pattern of squares, usually between 10 meters and 20 meters apart over the surface of a site. At each point on the grid, an archaeologist will normally place a shovel test, a square hole 50 centimeters wide and usually a meter, about 39 inches deep. The soil that comes from each test will be screened through a wire mesh screen that can be shaken to get rid of the soil, leaving any artifacts behind in the screen. As the tests are dug, archaeologists bag the artifacts they recover, draw a profile or a side view of the different levels of soil and any features they find, and draw a map of the places they found artifacts and what kind of artifacts they found. Once subsurface testing is done and archaeologists have an idea about where different types of artifacts at a site are coming from, the principal investigator will decide if and where block excavations are to be done. Block excavations are what most people think of when they think of archaeology. They're larger square or rectangular units, usually 2 meters by 2 meters, or roughly 6 feet by 6 feet square, that are dug in levels, the layers of soil going downwards as they're dug. As an archaeologist excavates each level, the soil is screened to recover artifacts. As each level is completed, any features such as post moles, fire pits, building foundations, or trash pits are drawn onto a map that shows their locations and relationships with other features and artifacts. The artifacts that are found from each level are bagged separately from the other levels. That's because of the law of superposition. The law of superpositions says that unless someone comes along and disturbs the soil later, the deeper you dig, the older the soil. That means, generally speaking, that artifacts from the upper layers of soil will be more recent than artifacts found in the deeper layers. During block excavations, as larger areas are opened up, archaeologists may be able to find the places where structures once stood. For example, at the Tree Lawn Plantation site, the work that's been done so far has helped archaeologists studying the site to find what appears to be a building that was used first as a kitchen in the early 1800s and then as a residence where people lived after the Civil War. Keeping good records when a dig is going on lets archaeologists learn more about what was happening in each part of the site. Finally, once the archaeologist has dug just enough to answer their research questions, and no more, the units that have been dug are filled in and recorded so other archaeologists can come back to the site later. And then some of the most important parts of the dig begin. So, we've successfully figured out everything we could about the people we're studying from the historical records. We figured out where archaeological sites connected with the people we're studying are located. We got permission from the landowner to dig, did all of the non-invasive testing that we could, then figured out where to dig through testing. We finished subsurface testing, completed our block excavations, and filled them back in after collecting the artifacts and mapping the features and soils at the site. Mission accomplished, right? Wrong. Once we finish the dig, we still have a lot of work to do if we want to understand what was happening at the site. In this stage of archaeology, we're taking the artifacts and information we got from the field and using some very special tools and techniques that can tell us a lot more about what was going on at the site. First, laboratory cleaning, drying, analyzing, and bagging. When artifacts are brought to the laboratory, they're cleaned of remaining dirt gently and then laid out to dry. When they're completely dried, the artifacts are sorted into categories: types of ceramics, types of stone artifacts, types of metal, types of glass, and so forth, counted and weighed. This lets archaeologists studying the site figure out where the different concentrations or groupings of artifacts are located and how many of each kind are in different areas. Second, some types of artifacts won't survive unless they're conserved. Conserving artifacts means treating them so they will survive longer. One of the most common kinds of conservation, called electrolysis, is done with iron artifacts. When iron artifacts first come from the ground, they may be so badly rusted that it's hard to tell much about them, or even in some cases exactly what they are. Electrolysis takes rusted iron artifacts and puts them in a chemical solution of water and sodium hydroxide. The artifacts then have an electrical current pass through them and the solution, as well as a sacrificial anode, usually made of fine steel wire. As the current passes through the artifacts in the solution, the chemical process of rusting is stopped, and the atoms of the rusted iron replaced partly with atoms from the sacrificial anode. When the process of electrolysis is completed, the iron artifacts are scrubbed and dried. Then, when they're very dry, the artifacts are saturated in a bath of wax or sealant to keep them from ever rusting again. Here we have examples of unconserved iron artifacts, and here below them, iron artifacts after electrolysis and conservation is done. As you can see, doing electrolysis can make a huge difference in preserving and interpreting iron artifacts. In doing electrolysis and conservation, it's important to always do it safely. So at the beginning, here are some important rules to follow. Always make sure to wear protective clothing, including gloves, a mask or goggles, and a covering apron. Never touch the rack or reach in the solution while the chargers are working. Always make sure they're unplugged. Make sure the area you're using for electrolysis is well ventilated, including a ventilation fan or a completely open space. And when doing conservation with hot wax, make sure you place the artifacts in the wax and remove them with tools. Never touch hot wax with your bare hands. Another helpful tool for archaeologists is the microscope, especially when trying to understand what an artifact is, if it's small, or what it's made from. Through using a microscope in combination with a camera and a computer imaging screen, an artifact under the microscope can be projected onto the screen to make seeing it much easier and to help find out what things were used to make it. If an archaeologist wants to know what elements are part of an artifact, a new technology has become available called X-ray fluorescence, or PXRF for short. A PXRF scanner uses a strong burst of X-rays to break down an artifact's composition and project the different elements it's made from into a computer. This means that archaeologists can look inside an artifact's composition and tell differences, for example, between lead or iron or pottery from Spain in the early colonial period or the United States from later in American history. Finally, after all of the data have been gathered and the archaeologist has information to share about what they've done, the most important tool for them is the computer and the internet. When archaeologists have completed a dig, they have an ethical obligation to publish their work so that other archaeologists and the general public can learn more about the things they've found. Through publishing articles, blogs, and social media postings, as well as creating online archives and databases, archaeologists can share what they've learned with the rest of the world.